Hello again, this is Math 145, day 11. We're talking about lesson 9, trig identities. This time applications of those two really basic identities, the addition formulas of sine and cosine. I'm going to write them down. Sine alpha plus beta is sine alpha. Cosine beta plus cosine alpha sine beta, and then cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So what can we do with them? I've got three examples to take this out for a spin. The first one, the sine of 75 degrees. Find an exact value of the sine of 75 degrees. Maybe pause the video, think about it for a second. Could we use an addition formula in some way? Think about it, pause the video. And I'm going to give it away. "75 degrees is, of course, 45 degrees plus 30 degrees. And we know the cosine and sine values for both of these. So that is tailor-made for an application of the addition formula for the sine. Sine of 75 is sine of 45 cosine of 30 plus cosine of 45 times sine of 30. And we know what these are. This is 1/2 square root 2 times 1/2 square root 3 plus 1/2 square root 2 times 1/2. And you can factor out square root 2 over 4, of course. What's left? Square root 3 plus 1. It's a nice formula. It's an exact value. Of course, anyone can type that into a calculator, but we got something extra that we did not know before. So that's kind of nice. You can think about possible exam problems. There's a couple of other angles. I'm going to do one more tomorrow where we could figure out exact formulas with square roots, things in them, using this addition formula toolbox. But my second example is something that is actually much more common. Things like this: the sine of pi plus x. So pi is pi, x is a variable, and the addition formula doesn't care. We can substitute variables, constants. It's always true. So this is sine of pi cosine of x plus cosine of pi sine of x. And the sine of pi is 0. And the cosine of pi is -1. So the end result is negative sine of x. We knew the sine of 2 pi plus x is the same. But if you only go halfway, then you flip the sign, as in sin, on the sine function. We did not know that before. Maybe we guessed it from the graph, but now we really know. And this kind of thing is really useful. You can do the same thing, same sort of thing with pi over 2 and see where it gets you. But we'll do a last example, which is very much from the textbook, so expect homework questions like this. Find the exact value of the sine of arcsine 1/3 plus arccosine of 2/3. Okay, what can we do? It's definitely worth introducing names for these quantities. Call that one U, call that one V, and we are ready to use the addition formula for the sine. Looking for the sine of U plus V, which is sine U cosine V plus cosine U sine V. What are those four quantities? The sine of U is the sine of arcsine of 1/3. We had those before. Remember those? Think. I'm deliberately stalling, give you a few seconds to think. That's 1/3. Next, what's easy? The cosine of V. Is the cosine of the arccosine of 2/3. What's that? 2/3. A little trickier, the cosine of U. For that one, we need to use Pythagoras. So this is going to be plus or minus the square root of 1 minus 1/3 squared. And the nice thing about cosine, arccosine, and sine, arcsine was that you actually always get the positive square root. It really is not the negative choice here. From Pythagoras itself, we just get plus minus. We should note this from Pythagoras. We get this with a plus minus deal because we only know cosine square plus sine square is 1. Same thing happens with V. The sine of V is square root of 1 minus 2/3 squared. But arcsine and arccosine are both defined so that the plus sign is the correct sign. And you could go back and read up on that in the textbook or watch some old videos. We're not going to go there. The plus sign is right. Now we're ready to find sine of U plus V. That's what we're after. So it's sine U cosine V. You got them listed. There's 1/3 times 2/3 plus cosine U sine V. So that is the square root of 1 minus 1/9 times the square root of 1 minus 4/9. I'm going to simplify this a bit. This is 2 over 9 plus square root of 8 over 9 times 5 over 9. And you can pull out the 9 and you get 2 plus square root 40 divided by 9, the whole quantity. So that's a little bit like a magic trick. And second example is the one which is most important for applications, this one. But the first one and the third one aren't so bad either. So any of that will show up in homework. We'll do more examples in lecture. But this is the videos for today. See you in lecture. Good night.